Okay. Ayan. So, good afternoon. Ay, good afternoon. Joke lang. Sorry. Good morning. Today, two lectures lang tayo. So, we start with the energy and applications of simple harmonic motion. Right? So, I think last week, tama ba? Na-discuss nyo na yung basics ng simple harmonic motion. Fundamentals niya like wave number, frequency, period, etc. Right? Yun yung mayroon sa simple harmonic. Ay, sa mga simple harmonic motion. Right? So for this lecture, we want to relate yung mechanical energy to the quantities na involved dun sa SHM, and then apply some conservation laws, specifically conservation of energy to systems with simple harmonic motion, right? And energy. Yeah, okay. So this is the energy in simple harmonic motion. So marami equations na nasa screen ngayon, but essentially, ang kailangan lang talaga dito is yung form, right? Form ng total energy for any system na exhibiting simple harmonic motion. Okay. So first na titingnan natin is yung spring mass system, right? So remember, yung spring mass system, may oscillation, may restoring force, right? May potential and may kinetic energy. Okay. So the total mechanical energy for the spring mass system is given by K plus U. Okay. So dito, ina-assume natin na walang friction, like spring mass lang talaga, walang siyang friction, walang tension, etc. So we just have that the mechanical energy should be K plus U, right? Where K is yung 1/2 mv squared, and then U is the potential, yung Kx squared, right? So dapat naalala nyo to from your LE1. Right? For spring mass system. Okay. Now, for any oscillation, again, recall that the oscillation position over time, or the instantaneous position, is written as a cosine function, right? In this formula, right? Where A here is the amplitude, omega is your frequency, the angular frequency, and phi is a phase. So it's a phase factor or displacement. So any system undergoing simple harmonic motion always have this position over time, this instantaneous position. Okay? Magbabago lang yung form ng omega depende sa type ng system. So makikita natin yan later on kung paano nagbabago yung omega. Okay? Now, to get the velocity for any simple harmonic motion, kukunin lang natin yung derivative nung x of t, right? So again, remember from your very first lecture, v is dx over dt or delta x over delta t, right? So yung delta x over delta t na formula, yung mga may delta, this is for discrete, right? Discrete values. So discrete yung change in position, discrete yung change in time. Kasi nung lecture 1, di ba, parang sinasabi nila t equals 0, t equals 1, t equals 2, etc. Now here, continuous na yung pag-change. Right? Continuous na yung change. As you can see kanina nung habang gumagalaw pa yung spring mass system, right? So with the continuous change, nagamit na tayo ng derivatives. Okay. So derivative ng x ng position over time. So derivative ng cosine is negative sign. So kaya may negative sign dito. Okay. And then derivative, and then chain rule, derivative ng nasa loob. So with respect sa time, right? Which will just be omega. So may lalabas kang omega. Okay. So negative omega A sine omega t, yun yung velocity. Okay. For the acceleration naman, ganun ulit. So acceleration is a derivative naman ng velocity over time. Okay. So ito yung velocity mo, constant yung omega, saka A, right? So lalabas lang siya. So meron tayong derivative ng v dt. So lalabas yung negative omega A, right? And then derivative no sine, which is just cosine. Malito. Dapat cosine. Cosine ng omega t plus phi. And then derivative ulit nung nasa loob ng cosine. So chain rule. So may lalabas kang omega. So omega squared. Kaya nakuha ito. Okay. So this should be cosine. This should be cosine. Okay. Ayan. So yan yung mga instantaneous values for any simple harmonic motion. So laging totoo yan sa any type of system. Now, in this system, sa spring mass system, yung restoring force only acts on the horizontal direction, right? So since ganito yung galaw niya, yung restoring force is only acts on this direction, right? So hindi natin kailangan ng y dimension or z dimension for this, only x dimension. Okay. And this restoring force is the only force that does work on the system, right? Kasi hindi naman siya subjected into any friction, o hindi siya subjected into any tension, etc. So yung restoring force na to, F sub R, yung restoring force, yan lang yung nag-work sa system. Hence, yung mechanical energy is conserved. Okay. Kung conserve yung mechanical energy, then yung potential and kinetic energy are both conservative forces. Okay. Okay. Okay, so now meron tayong equations for x and v. So we can now plug in this x and v dun sa conservation of energy na equation. Right? So 1/2 mv squared plus 1/2 kx squared. Plug in natin si v dito sa kinetic energy at si x dun sa potential energy. Okay, so plug in lang yan. And then simplify. So dito meron kang negative omega squared a squared, right? So magiging omega squared r squared. So negative times negative, positive. So mawawala yung negative na yan. And then sine squared nung expression. Sa potential naman, ganun din. So meron kang a squared na lalabas na constant coefficient. And then cosine squared nung nung expression. Okay. So here, dito natin makikita yung isang form ng omega. So yung omega, yung angular frequency for the spring mass system can be taken from this expression. Right? So itong to. So gusto natin i-equate itong dalawang terms na to, or hindi naman i-equate. Gusto natin na mapag-add sila. Like gusto natin silang mapag-combine. Right? So equate natin tong terms na to, m omega squared equals k, right? So omega squared equals k over m, or omega equals square root of k over m. So yung angular frequency for a spring mass system is given by square root of k over m. Okay. So with that, pwede nating ipasok tong K over M na to dito sa expression na to. Right? So omega squared will just be K over M. Right? So magiging K over M na lang yan. Tapos may M ka dito, so magka-cancel yung M. So may iwan din lang dito ay K. Same as here. So meron ka lang K dyan. So pwede mo na silang i-add. So 1/2 K squared lalabas, and then you have this expression sine squared plus cosine squared ng omega t plus phi. But remember, any expression of the form sine squared x plus omega squared, plus cosine squared x, lagi yang 1, right? So this whole expression is just 1. So may iwan na lang ay 1/2 K squared. So the total energy for the spring mass system is given by 1/2 K squared, Ka squared, where A is the amplitude and K is the force constant of the spring. Okay. So kung 1/2 Ka squared yan, so alam natin 1/2 Ka squared to, itong left hand side dito. So we get this final equation. Okay. Clear ba ito? Clear ba kung paano nakuha yung 1/2 K squared? Ka squared pala. K squared. Okay. Okay, so clear naman. Okay. So dito nakita natin, thank you for the relax. Dito nakita natin yung isang form ng omega ng angular frequency, which is square root of K over M. Now, to get the speed at any point, ito na yung equation niya. So V of x, right? So V of x lang yan kasi along x lang yung motion natin, right? It's just the positive or the negative root of square root of K over M times A squared minus X squared. Right? So ito, pwede mo itong ma-derive actually from the velocity and the acceleration. Itong dalawang to. Negative K over M. Right? Okay. So lagi niyong tatandaan to. Dalawang to. Okay. Paano po pala na-assume na M omega squared equals K? Actually, it's a it's a trick. Ano ba explain? Ito kasi, 'di ba meron tayo ditong kinetic, right? Yung sa kinetic energy saka yung sa potential energy. Ngayon, gusto nating mapag-add. Gusto nating ma-simplify yung form ng total energy, right? So gusto nating ma-simplify yan. So kailangan nating mapag-add itong dalawang terms na to. Okay? So in a sense, kailangan nating malabas itong term na to saka itong term na to. Kasi alam natin na yung sine squared at yung cosine squared, pag in-add natin, like yung nangyari dito, magiging 1. Right? So how do we want, paano natin gagawin na such that itong terms na to, itong coefficients na to, is nasa labas ng both terms, right? Yung coefficients na yan. So we want to equate yung amplitudes nila, ay yung coefficients. Okay. So actually, yung nangyari is 1/2 M omega squared equals 1/2 Ka squared. Ay, 1/2 M omega squared A squared equals 1/2 Ka squared. Okay. So mawawala yung 1/2 kasi parehas meron. Mawawala rin yung A squared. So matitira ka ng M omega squared equals K. So simplifying for omega, we get square root of K over M. Okay. So if omega is equals square root of k over m, pag pinasok natin dito, yung k over m, ay, so naka-square yan. Ay, hindi na pala naka-square kasi omega squared equals k over m. So magka-cancel yung m and we are left with 1/2 ka squared. Same dito sa 1/2 k squared. Angular, okay. Sir, same lang po ba yung Vt at Vx? Hindi. Not necessarily. Okay. Si Vt is instantaneous velocity over time. Right? Well, paano? Yeah, I think same lang siya. Yes, same lang siya, pero in a different form. Kasi dito, sa V of t, right? Hindi natin ma-extract mismo yung x of t, right? Hindi natin siya makukuha from the sign. Actually, isi-shift mo siya. Isi-shift mo with the minus the phi para maging cosine yung sign. Tapos mapapalabas mo yung something v v equals something ng x, kung ano man yung something. But to get that, mahirap siyang i-derive. So ibinibigay na lang usually itong v of x. Okay. Pero essentially same to, except that iba yung form. Kasi ito ay dependent sa time, ito ay dependent na lang sa position. Okay? Okay ba yan? Okay. So may isa pang question. Angular velocity pa rin po yan. Yes, omega still the angular velocity. If you check itong relationship na to, either omega equals square root of k over m or yung m omega squared equals k. If you check yung dimensionality constant, anong tawag doon? Consistent yung dimension. Right? So m is kilograms, right? M is kilograms. Omega squared ay angular frequency. Ano yung angular frequency? Radians, something radians. Or distance, right? So something distance squared. Tapos yung force constant mo is ano ba yung force? Something distance squared. Force constant is Newton per meter. Actually, ito pala, distance over time. Kasi frequency nga pala. Something distance over time. Angular frequency. Ay, hindi. Mali. Distance over. So, S squared pala siya. Something distance. Wait lang. And frequency. Frequency. So, over S squared pala siya. Sorry. Angular frequency. Frequency. Tapos yung force constant mo is Newton per meter. But Newton is just kilogram meter per second squared. So magkakancel yung meter. So parehas na lang kilogram per second squared. So if you check in dimensionality constant, consistent siya. Right? So angular velocity pa rin siya. Okay. Any other questions? Any other question? Okay. So kung wala, let's continue. Okay. Yung ito pala, tong acceleration, actually madali itong makuha. So ito ay malito. Cosine to dapat kasi ng derivative. So madali itong makuha ang acceleration at any point kasi alam natin na yung a cosine ay yung x of t. So it's just this will just be negative omega squared. Yung a cosine is just x of t. Right? So yan na yung acceleration mo. And alam natin yung omega is square root of k over m. Yeah. So kung squared yon, magka-cancel ang square root. So magtitira ka ng k over m times x. So dun nakuha yung acceleration of m. So yan yung a sub x. So actually, halos same lang talaga. Same lang. Ay. Okay. Yeah, typo yung sa sign sa a of t. Dapat cosine. Cosine yan dapat. So actually, same lang talaga yan. Iba lang yung dependency. So same lang din. This is speed dependent sa position x or acceleration dependent sa position x. Ito naman ay dependent sa time. Okay. So pwede kasing ipahanap, like, halimbawa, hindi ka given ng time. So kailangan mo lang nung these equations kung hindi mo alam yung time. Kapag alam mo naman yung time, pwede mong gamitin ito. So something like that. Okay. Okay. Yeah. Okay, example. Given this following initial configuration of a glider setup, yung nasa taas, okay. Find the maximum and minimum velocities when x equals 0. So again, here, isang example to na hindi given yung time. So, right? Hindi rin given sa atin yung ano yung form ng x of t nung position versus time. Right? So, for here, we just use yung equation for velocity dependent sa position. Kasi alam natin yung position. Right? Initial or when x equals 0. So, x equals 0, ito yung equilibrium position. Okay. So, this is x equals 5. Right? And this is x equals minus 5. So, yung equilibrium position niya is somewhere here. Yan. Okay. So, ano yung maximum and minimum velocities? So, we just use yung formula kanina for the position. Velocity dependent position. Dependent sa position. Okay. So, ito yon, right? When x equals 0, ito yon. So, mag-0 lang to. So, we just have k over m times square root of a squared. Okay. So, given tayo ng k, 200 newtons per meter. Given tayo ng mass, which is 0.50 kilograms, right? And given tayo ng maximum distance, which is 0.02 meters. Okay. So, plugging in our values, we get this velocity, 0.4 meters per second. Right? So, actually, plus minus yan. Plus minus yan lang. Kasi may plus minus yan. So, ibig sabihin, yung maximum velocity is yung positive 0.4, right? And yung minimum velocity is yung negative 0.4. So, if we just want to find the maximum velocity, kunin lang natin yung positive root ng k over m, tapos times the amplitude A. Okay. So, this is always the case kasi ang maximum velocities happens at equilibrium. Right? Kapag dumaan siya sa equilibrium. Right? Here. Now, for letter B, find the velocity and acceleration halfway from starting position to the equilibrium position. Okay. Ang starting position natin is yung amplitude, yung max amplitude, which is 0.02. Halfway, so paano natin kukunin yung halfway? So, ito yung x equals 0. Ito yung equilibrium position. Yung maximum amplitude niya ay 0.02. Right? So, halfway, we know that halfway is at 0.01. Okay. So, ano ngayon yung velocity and acceleration here? Right. So, yung velocity, we just use the same equation. Ito. Pero iba na yung x. Yung x natin kanina is 0 kasi equilibrium yan. So here, halfway siya. So magiging 0.01. If we plug in our values, we get a velocity of negative 0.35 meters per second. Bakit negative? Okay, so bakit negative? Any idea bakit siya naging negative? Kasi, yes, kasi yung, diba, ito yung x equals 0, ito yung equilibrium, dito siya nag-start, 0.02, right? So alam natin at halfway, right, yung, tawag dito, yung glider is moving towards that side, right? So from this initial position, halfway, nag-move siya to the left, which means negative yung direction. Paano malalaman kung saan nag-start sa amplitude? Ito kasi yung initial configuration mo is 0.02. Yun yung sinabi dito sa setup, right? So we set that the starting position is this. So given siya. Okay. And kung yun yung starting position, right? For any simple harmonic motion, usually yung starting position, yun na yung max amplitude. Yun na yung A. Right? Kung given ka ng ganitong setup. Okay? Okay? So at this position, right? At this position naman, alam nating pa-left si glider, right? Kasi dito siya nag-start and then pupunta siya sa equilibrium position which is on the left. Right? So yung direction niya is negative. So kung from that, yung kukunin mo is yung negative root of this equation. Kaya naging negative to. Okay. If dumaan na, halimbawa, alam natin na yung max amplitude sa kabila is nasa 0.02, right? Or negative 0.02 x, right? Kung nandito naman na siya, right? Kung galing siya dito, ito yung initial position mo, yung negative 0.02, kung yun yung initial position mo, right? So yung direction ng velocity, magiging pa ganito. Kasi kailangan niya bumalik sa equilibrium. Right? So with that, ang kukunin mo naman is positive root. Okay? Okay. So kaya important kung ano yung initial position sa kayong final position. Okay. Para malaman natin kung positive or negative root yung gagamitin. Okay. Pero yung sa dulo, right, yung sa amplitude mismo, yan yung maximum and minimum velocities. Okay. Any other questions for this? Yes po.
Bali po yung starting position po is yung 0.20 meters po, di ba?
Yes po.
Tapos yung equilibrium position po ba niya yung ano po, 0.010. So, from that, tas papuntang left po.
No. Yung equilibrium position is always at x equals 0.
Okay.
Okay. For any spring mass system, right? Gusto natin na yung origin nasa equilibrium. So x equals 0. Okay. So kung x equals 0, yes, yung halfway, kasi kailangan natin halfway. Halfway. So starting, which is 0.02, equilibrium ay 0. So ano yung halfway? Ano yung pagitan nila? Yun yung 0.01. Okay. So yun yung ipapasok natin na x. Kasi halfway yung tinatawag. Okay. Okay, for the acceleration naman, gamitin natin yung other equation kanina. So negative k over m times x, right? Yung maximum and minimum acceleration always happens at the amplitude. Sa negative and positive amplitude. Okay? So yung sa dulo, right, dito sa dulo, saka yung dito sa kabilang dulo. So if we plug in our values, we see that that is negative 8 meters per, negative or positive 8 meters per second squared. Again, depende kung nasaan amplitude ka. So kung nandito ka sa negative A, negative yung acceleration. Kung nasa positive A ka, positive din yung acceleration. Okay? Pero yung acceleration halfway is a different story. Okay. So meron ka pa rin ng negative k over m times x. But here, yung x natin is again nasa halfway. So if we plug in our values, yung acceleration at this point, at this instant, is just 4 meters per second squared. And this now makes sense kasi alam natin na yung maximum acceleration happens at this A. So dapat yung acceleration na makuha natin dito is mas maliit. Okay. Same with the velocity, right? Yung maximum acceleration happens at the amplitude A. So dapat yung makuha natin values ng mga velocities in between should be less than. Okay. Any questions here for this exercise? Okay, so wala namang questions. So we can proceed to application, right? For some applications of the simple harmonic motion. Okay. Actually, isa na pala yun yung spring mass system. This is now a different system. It's a simple pendulum. Right? And makita natin dito na iba na yung form ng angular frequency. Okay. So for the spring mass system, yung restoring force natin, remember, is negative kx. Right? Sa spring mass system. Spring mass system. But for simple pendulum, ang restoring force is given by negative mg sine theta. So bakit? Kasi ito yung simple pendulum. Ito yung simple pendulum. Now, if nilift mo yung mass m, right, at this initial height or initial angle, yung equilibrium position niya is yung kapag straightened down lang siya. So our intuition says that yung motion ng pendulum will tend to go towards the equilibrium position. Right? And ano lang ba yung force, right, na nag-act for a simple pendulum? It's just the the weight, the force of gravity. Right? It's just the force of gravity. Okay. Meron ding tension, pero hindi nakaka-affect yung tension sa restoring force. Kasi yung restoring force mo is just along this axis. Right? So dalawa yung forces dyan, may tension, may Fd, pero yung restoring force mo is along this axis or yung axis na to. Right? So yung force lang na nandyan is yung component ni weight that acts on that axis. So kung sabihin natin yan yung x-axis, ito yung y-axis. Right? So along x-axis, ang force lang natin is Fg sine theta, which is just mg sine theta. Okay. Negative siya. Bakit? Kasi it's a restoring force kasi it acts on the negative, sa negative direction. Okay. So yun yung restoring force for a simple pendulum. Now, if we take into account ang small angle approximations, so meaning, for very, very small angles or very small angular oscillations, like gusto mong ipa-oscillate tong pendulum in very small angles, yung motion ng simple pendulum is approximately a simple harmonic. Okay? So, magiging simple harmonic motion na si simple pendulum. Tapos yung application yan ng small angular approximation is just this. Sin theta is approximately theta. So, pwede yung itry sa calcul nyo at very, very, very small angles. This is true. Right? So, kung sin theta is approximately theta, then this will just be theta. So, negative mg theta na lang yan. Where theta, itong initial angle natin, right? So, pwede tayo magsokatowa to get kung ano ba yung value ng theta. So, theta is just, ano ba to? Opposite, yung original niya, sin theta, right? Yung original niya, sin theta is just opposite yung ito, yun yung displacement x, let us call it x, over the hypotenuse capital L, right? So, yan yung original na definition ng sin theta for this system. But now, we approximate sin theta to be theta. So, that theta is just x over L. So, i-plug in natin yan dito. And then, we use Newton's second law. So, F equals ma. Right? So, ma equals negative mg over lx. So, magkakancel yung m. We get the acceleration to be g over l times x. Okay. Now, this is the form na nakuha natin, but we can compare it dun sa default na acceleration for a simple harmonic motion. Right? So, kanina sa spring mass system, sabi natin, ax equals negative omega squared x. Right? So, again, nakuha siya dito. Dito. Right? So, kung cosine yan, so ax or a equals omega squared x. Negative omega squared. So, doon siya nakuha. If you remember. So, pagdating dito, if you compare yung expression na to sa expression na to, so may yung x nandyan, yung negative nandyan. So, we get omega squared equals g over l. Okay. Or omega is square root of g over l. Okay? So, kaya yung kailangan nyo lang talagang i-memorize actually is yung form ng angular frequency for different cases, for different systems. Right? Kasi ito, laging constant to for any system. Right? Itong mga definition ng itong mga definition na to, constant to for any simple harmonic motion. Magbabago lang yung values niya, depende sa omega. Okay. So for simple pendulum, omega is square root of g over L. So yung frequency, kung given ka nito, so meron ka na lang 1 over 2 pi square root of g over L. And the period is just 1 over frequency. So babalik ta rin mo lang yan. Magiging 2 pi square root of L over g. Okay. So hindi nyo kailangang i-memorize itong mga stuff na to. Right? Ang better i-memorize is this, if ever. And yung forms ng omega for different systems. Yun yung kailangan talagang maalala. You just have to remember those. Okay. Any questions so far? Okay, so wala naman. Let's move to examples. Okay. Sample 1, you are on a planet where you have no idea what the acceleration due to gravity is. Using a simple pendulum of a mass 1.5 kilogram and length 0.8 meters, you want to calculate, of course, the acceleration due to gravity, g. You were able to determine that it takes 34 seconds for the simple pendulum to complete 10 cycles. So what is the value of g? Okay. So meron tayong 10 cycles na na-complete. So meaning, pwede natin ma-compute yung period. So ang period, total period is 34 seconds over the 10 cycles. Okay. Kasi it takes 34 seconds to complete all of the cycles, all of the 10 cycles. Okay. So if we divide the time by the cycles, then we get the time it takes for one cycle to complete. And that is 3.4 seconds. Okay. Now, simple pendulum. So, gagamitin natin yung formula for the period ng simple pendulum. And that is 2 pi square root of L over G. Right? Where T is 3.4 seconds, L is 0.8 meters, and then mass is 1.5 kilograms. So we can now isolate G. So here, G yan, is equal to L over the T over 2 pi squared. Plugging in our values, we get this acceleration due to gravity. 0.028 meters per second squared. Okay. So makikita nyo, actually, kahit may mass tayo na 1.5 kilogram, independent yung equation natin ng period dun sa mass na yun. So any mass will do, kahit ano pa yung mass ng simple pendulum, as long as exact or accurate yung pag-measure mo ng time and ng cycles, then makukuha mo yung value ng G. Okay? Now, this is the case for the simple pendulum. Paano ngayon kapag physical na yung pendulum? Right? So, sa simple pendulum kasi, the simple pendulum, we assume may yung mass is concentrated on the end. Right? Nandito lang lahat ng mass. So, we assume na yung string ay massless. But for a physical pendulum, hindi na natin pwedeng i-assume na massless yung string or yung kung ano man siya naka-attach, right? So, pwedeng may mass na rin itong kung saan siya naka-attach. Okay. So, for any pendulum, for any physical pendulum or rigid pendulum, for any rigid body na pendulum, kung ito yung pivot point, right? Ang kailangan nating malaman is yung distance nung center of mass nung buong pendulum, right? From the pivot point. Yun yung tatawagin nating D. Bakit? Kasi sa center of mass, nag-a-act yung weight or yung force of weight, force due to weight. Kasi center of mass is similar to center of gravity. Right? So, doon sa center of gravity ng buong pendulum, kung ito yung pendulum mo, right? Kung yan yung pendulum mo, so sa center of mass, mag-a-act yung weight ng pendulum na yan. Okay. So, with that, yung equation natin will become this. So, ito na yung position over time ng buong pendulum. Or acceleration pala. Acceleration over time ng buong pendulum. Where again, M is the mass of the whole pendulum. Right? D is the distance of the center of mass from the pivot point or from the axis of rotation. I, inertia, is yung inertia nung kung ano man tong nagro-rotate. Right? Kung ano man yung object na nagro-rotate. Okay? Now, applying small amplitudes, we get these equations. So, ang form naman ng angular frequency is square root of mgd over r. So, ito na lang yung angular frequency. Square root. Something like okay. And then F frequency is 1 over 2 pi times omega. So, yan yung papasok. And then the period T is 2 pi 1 over F. 2 pi times 1 over F, which is kabaliktaran. Okay. So, ito lang yung critical dito. And this, of course, yung acceleration over time. Okay. Any questions so far? So, again, yung D dito, right, yung D na to, is yung distance ng center of gravity or center of mass from the pivot point. Yung I, yung moment of inertia ng buong pendulum. Okay. So I think better siya if makita natin with an example. Okay. For example, a meter stick swings about a pivot point O at one end at a distance h from the stick's centers of mass. Okay. So what is the period of oscillation? Okay. So yung h daw, yun yung distance from the center, ay yung distance ng center of mass from the pivot point. Okay. So here, yung h na yon is 1/2 L over 2 if yung L yung buong length ng buong pendulum. Okay. And remember, yung moment of inertia ng rod or ng isang ng rod, rotating at one end is 1/3 ml squared. Okay. So if plug in our values, so for the period, so period is 2 pi times square root of I over mgd, where d again is the distance from ng center of mass to from the pivot point. So it's just h. And h is 1/2 L. Yung I natin, yung moment of inertia is 1/3 ml squared. Right? So magka-cancel yung isang L dyan, magka-cancel yung m. Matitira ka na lang ng 2/3 L over G. 1/2 mapupunta sa taas yun. Okay.
Sir?
Wala to. Hello? Sige.
Okay.
Okay. wala yan. Hindi given yung L. I think yung L yata dito ay 2.5 meters. Pero hindi given sa problem. Don't mind that. Okay. Any questions? Any questions? Okay, so wag mali ito yung D na yung nandito sa equation is always the distance ng center of mass from the pivot point. Okay. So kung given kayo ng pendulum, right? Pero ba may rod, ito na lang. Sige, may rod tayo dito, tapos may additional mass na nilagay dyan. Something. So kailangan nyo makuha yung bagong center of mass. Right? Kung maglagay tayo ng mass dito, sabihin natin naglagay tayo ng clay dyan. So kailangan nyo i-compute yung bagong center of mass. Right? So paano ulit kinukuha yun? Yung bagong center of mass or center of gravity? So meron kang xm equals x1 m1 plus x2 m2. Right? So para makuha yung distance na yon ng bagong center of mass, we just have this x1 ito yon yung H. M1 yung sa pendulum, ay yung sa rod. Plus X2 here, that is L, right? Kung nasa dulo yan. Times yung mass nung, kung ano man yung nilagay, mass ng clay. Over yung total mass, which is M plus MC, yung mass ng clay. So makuha mo na yung X, yun yung bagong center of gravity, which is around here. Okay. Tapos with that, yun na yung bago mong D. Yun na yung bago D. Okay. So medyo mas madugo yung physical pendulum kasi marami kang extra steps to get kung ano yung center of mass, center of gravity, etc. Okay. May nag-raise ng hand. Okay.
Sir, clarify ko lang po dito po sa may, pag may additional mass po. Ano po
Yes.
yung magiging, second na X po?
Second na X.
I mean, di ba po yung
Ay,
formula?
ito.
Opo. Ayun po. Ano po yung dalawang yan?
Yung, okay. Yung X1 natin, ito yung sa rod, right? Yun yung sa rod. So, yung initial na center of mass ng rod is nandun sa gitna, which is H, or 1/2 L, right? Tapos yung M1 is yung mass ng rod. Yung clay na in-add natin, for example, may nag-add tayo ng clay, sa dulo, kung sa dulo nilagay, then yung X2 niya is nasa dulo, which is L.
Okay po, sir. Thank you po.
Okay. Tapos, yung M2 is yung mass nung nilagay mo, mass ng clay. Kaya MC yan. Okay. So, ganun lagi. Kung saan nilagay yung mass. Kung dito nilagay yung mass, edi magiging H over 2 yung ano na to, X2. Okay. Or some other distance. So, ganun siya. Kung saan nilagay. Para makuha yung new center of mass or new center of gravity. Okay. Any other questions? Thank you. Thank you for your questions. Wala. Okay, so I think this will be our last example. Okay. A mass in a simple harmonic motion oscillates with an amplitude A and angular frequency omega. What is the position from equilibrium and velocity of the mass if the kinetic energy is twice the potential energy? Okay. So, dito, sabi niya, yung kinetic energy is twice ng potential energy. Okay, so alam natin ngayon yung energy. Right? So gagamitin natin yung conservation of mechanical energy, right? Which is K plus U. So if K is equal to 2U, right? K equals to 2U, plug in natin yung 2U dito sa K, right? So we will get the total energy equals 3U. Ano yung potential energy? It's just 1/2. Ay, ano yung total energy? Yun yung 1/2 Ka squared. Right? And then yung potential energy is 1/2 Kx squared. Okay. So yung 1/2 magka-cancel. Yung K magka-cancel. We are left with A squared equals 3x squared. Or x equals A square root of 3. A over square root of 3. Right. Ito na yung position. Dali lang, di ba? Joke. So actually medyo medyo madaling mag-compute, madali yung math ng mga problems sa simple harmonic motion. Ang kailangan nyo lang malaman is ano yung gagamitin. So kung like, anong formula for the angular frequency, anong formula for the position, ay sa period, sa total energy, etc. Right? So how about the velocity? Saan naman natin makukuha yung velocity? Sige nga, any ideas saan natin makukuha yung velocity? Okay. Sa angular frequency po. Yes, pwede. Pero hindi given yung angular frequency dito. Like we just know that it's omega. Sa kinetic energy po. Technically, yes. Technically, tama, sir. Sa kinetic energy, actually, we will just use the same equation. E equals K plus U. But this time, CU naman yung papalitan natin. So from K equals 2U, pwede nating ma-derive si U to be K over 2. Bakit? Ba't natin gustong gawin yan? Para pag pinalitan naman natin si U ng K over 2, meron tayong equals 3 halves K. Tama? And then, alam natin yung kinetic energy. That is 1/2 mv squared. So technically, tama. Sa kinetic energy kukunin yung velocity v. So total energy is 1/2 ka squared, 3 halves, tapos yung k is 1/2 mv squared. So magka-cancel agad yung 1/2, ano pa? Yun lang yung nag-cancel. So we will get v equals square root of 2 over 3 omega a. So bakit naging ganito? Natira tayo ay ka squared, 3 halves mv squared. Actually, tama din pala yung angular frequency. Tama rin pala. Kasi nandito rin siya. Right? Kasi yung omega equals square root of k over m. Right? So if we simplify that, ito yung makukuha natin. Okay, so actually tama si J and si Renz. Ipag-combine nyo yung ano nyo, yung sagot nyo. Okay, any questions? Any other questions for this? Okay. So again, to wrap up, I think yung important lang again is to memorize yung forms ng angular frequency for different types of system, kung spring mass, simple pendulum, or physical pendulum. Doon lang mag-iiba yung omega. Kasi yung formula for frequency and period, dependent sila sa omega. Okay. And laging huwag kakalimutan yung D dito sa equations ay yung distance ng center of mass from the pivot point. Okay, so actually, ganun din naman siya sa simple pendulum kasi yung center of mass nito, since we assume, right, since we assume sa simple pendulum na massless yung string, so nandito lang yung mass. So ito na yung center of mass ng buong pen. Kaya L yung ginagamit dyan. Hindi na D. Actually, halos similar. And then, wag din kakalimutan yung ito. 1/2 ka squared or these equations. And of course, this. Okay. So, yun lang yung key sa energy and applications in SH. Okay ba yan? Any other questions? Okay, so if wala na, I think that's it for today. Medyo time na rin. So next week will be lectures, last lectures 33 and 34. So that will be waves in 3D and Doppler effect, I think. So Doppler effect. So dalawang last 2 lectures na lang. And then with regards sa FQ6 na hints, I think pag-usapan na lang namin ni Ma'am Jack kung paano i-send. Oh, so kasi I think deadline yun ng FQ5, right? Mamaya, today. So good luck sa FQ5. So sana patapos na kayo or konti na lang yung kailangan yung i-confirm. Okay. So with that, thank you for attending. See you next. Okay, may question? Sir, question po sa 3B, naka-PA pa po ba yung final answer na input sa OVLE or ATM? I think Pascals lang. I think Pascals. Let me double check. Let me double check. That will be FQ5. FQ5. Number 3. Tama, number 3. Number 3. Letter B. Kasi 180. Right. Yeah, I Pascals na lang. I think Pascals. Yeah, Pascals yung ano. Okay. Sige po. Ayun. So kung wala nang other questions, that's it for today. Thank you for. Saan po yung Pascals? Yung PA yung Pascals. Yung sa number 3B. So sa number 3B sa FQ5, Pascals yung i-input. In Pascals. Yeah. Okay. So yun. Okay. So if wala nang questions, yun, thank you for attending.
Thank you po, sir.
Thank you.
Thank you po.
Thank you.
Restore.